All right, so right here, what we're going to do is we're going to go ahead and discuss what we've got here. So previously, we determined trig values for an unknown angle measure using a given coordinate. If we want to know an unknown coordinate on a circle, we'll need to use the, what this is supposed to be here, then would be angle measure. So we'll use the angle measure and the radius of the circle. So utilizing that information, what this says right here, it says find the coordinate where the terminal side of an angle, being theta of pi over 6, or theta is pi over 6, it intersects a circle with radius length of 4. So pi over 6 is something that is on our unit circle, correct? It's actually in the first quadrant. It's equivalent to 30 degrees. So we're about right here. So I'm just going to, I cannot draw a straight line on here. So this is what we've got here. So that's saying that I've got this angle measure here, which is pi over 6, but we have a radius of a length 4. And we need to know what the coordinate point is for this. So I know in your mind, you're like, well, if it's pi over 6, isn't the coordinate point going to be square root 3 over 2 and 1/2? Well, that's if it's on the unit circle and the unit circle has a radius of 1, not 4. So square root 3 over 2 and 1/2 are not what we have. Because if you think about it this way, that would be like saying if I have a triangle. So let me do something over here. We know we have a 3, 4, 5 triangle. But if I change the radius and it's no longer 5, let's say it's 15, this is not going to stay at 3 and this is not going to stay at 4. Those are going to have to go up by the same amount as this one did. So this would instead, all of these would have to be 9, 12, and 15, right? Because this went up by a multiple of 3, so therefore these are as well. Otherwise, then my triangle wouldn't connect. So that coordinate point that I have of square root 3 and over 2 and 1/2, that's giving me a radius of 1, a hypotenuse of 1. Now I have a hypotenuse of 4. So visually, I'm just going to kind of do this a little bit of the long way, but it explains why we have what we have. So if I was to drop an altitude from that point to intersect my x-axis and create my triangle that I have here, if this is what I have and this is the angle I've got right here and I'm solving for x and y, well, if I wasn't thinking anything about pi's and radians and square root 3 over 2 and that, the way that you would typically have set that up would have been to go, all right, I've got to do cosine of pi over 6 is equal to adjacent over hypotenuse. So this is the cosine of my angle. My angle is pi over 6, and that's equal to adjacent over hypotenuse. And so if I was to solve that, solve for x, I would multiply by 4 to both sides. And now I have 4 cosine pi over 6 is equal to x. Well, what is the cosine of pi over 6? Well, that's what we were just saying, is it's square root 3 over 2. So the cosine of pi over 6 is square root 3 over 2. But this has a radius of 4, so we multiply it by 4. And so that gets me 4 square root 3 over 2, which these reduce, and it gets me 2 square root 3. So that's what I get from my x value on this question. So I'm going to put that here. My coordinate would have 2 square root 3 as my x. Now I need to find what y is. And so I'm going to follow the same process here, but if I solve for y, what trig function would that be? That would be opposite, and 4 is hypotenuse, so that would be sine. So I'm going to do, I've got I've got sine of pi over 3, or pi over 6. Sine pi over 6 is equal to opposite over hypotenuse. So again, I'm going to multiply by 4 to both sides. And that gets me 4 times the sine of pi over 6 is equal to y. Well, the sine of pi over 6 is 1/2. So y is equal to 2, because that's what 4 times 1/2 is, 2. So that's what my coordinate point is it's going to be at 2√3 and 2. And you can always double check yourself if you're really being extra cautious and really unsure about what you had. You can take what you were given here, or not what you're given, you can take what you found for your coordinate point and use Pythagorean theorem. If I did 2√3 squared plus 2 squared, that should, in theory, equal what my radius is squared. So this should equal 4 squared. And so I can double check myself. I can even put that in my calculator and do that. If I did 2 square root 3 squared, and the other one was 2 plus 2 squared, 2 squared, or 4. That equals 16. So I just double checked myself and made sure that I didn't screw up something somewhere and, make a simple, small little mistake. The gist of what you just did is the formula to find the coordinate point, if you're given the radius and an angle, is it's r cosine theta, r sine theta. That's how you find those values. And that's exactly what we did, because if you look right here and right here, that's exactly what we did. This is for cosine theta, and this is for sine theta, okay? All right, so let's scroll on down. How would we use the above information to find the tangent? So if we go back to this and look, I have this coordinate point of 2√3 and 2, where this one right here is my opposite, and this one is my adjacent. So to do tangent, it's y over x, right? So what I'm going to do here to find my tangent, that would be 2 divided by 2 square root 3. Well, these 2's cancel out, and I'm left with 1 over square root 3, which we should be able to do in our head right now, but just in case, we rationalize that, and that gets us square root 3 over 3. So my tangent here at pi over 6, but having a radius of 4, is still the exact same value that we had when we look at tangent of pi over 6 with a radius of 1. It was still square root 3 over 3, wasn't it? The reason for this is because tangent, at the end of the day, is a ratio of what you have here for your y divided by your x, okay? My radius is not going to impact that, because as I just said just a few minutes ago, if I had a 3, 4, 5 triangle, right? If I had a 3, 4, 5 triangle, as my hypotenuse gets larger, as this one gets larger, these are going to get larger by the same amount. It's the same multiple. So if I do y over x or sine over cosine, it's going to be the exact same ratio. It's going to reduce by the same multiple. So that's what ended up happening right here, is these 2's canceled out, and this is what I get. So is the tangent value dependent on the radius length? No, it's not. And that's what I just was explaining. So your tangent is not going to change dependent upon the radius, but the sine and cosine do, because those utilize just one of those, okay? Number 2, find the coordinate where the terminal side of an angle theta is equal to 5 pi over 9. Well, 5 pi over 9 is not on my unit circle. That's okay. We can go ahead and do it. We just kind of got to draw a picture and see what we've got to figure out where we're at. So if I have 5 pi over 9, let's try it. So this would be 9 pi over 9. This would be 18 pi over 9. Halfway between 0 and 9 is 4.5 pi over 9. So 5 pi over 9 is just over this. So this would be my angle, and standard position would be this, 5 pi over 9. So what I have here is I'm going to use this information. I have a radius of length 7. Don't overcomplicate it. As I gave you, it's r cosine theta, r sine theta. So now that's going to get me 7 cosine 5 pi over 9 and 7 sine 5 pi over 9. Okay, this is what I would get for those. Now, I'd have to put that in my calculator to get the actual coordinate, because I might have to reduce that down and figure out what I've got. So in order to do that, I'm going to put that in my calculator. Again, we're using radians, so it must be in radians mode. So I have 7 times cosine. And then what I'm going to need to have here, there's 2 ways you can do this. There's the way that most people will probably do it. And depending upon the calculator that you have, you might have to do alpha, which is this little green button here, then hit y equals, which is this top left button here. And then you see this number 1 is n over d. If I do that, it gets me the box over the box. A lot of people are going to prefer that. So again, that's alpha y equals enter. Some of the calculators as well, you can do alpha, and then you can go right next to the alpha button and hit this xt theta n button, and that also does it too. Okay. Alternatively, I could actually, here, let me enter it in here. So we'll do 5 pi. Pi is above this arrow up button. So we've got 5 pi over 9. So that's 1. Okay. I can also do this as 7 cosine. You just have to be really comfortable with your parentheses. So put the entire numerator in parentheses. So I would do 5 pi. And then your denominator, the entire thing would have to be in parentheses if you had more than just a single number. And then I'd have that. And so you see, I can put it in either one of those ways, whichever way you're more comfortable with, whichever way works with the way that you understand your calculator and what you see. Those get me the same value, it's fine. So that gets me negative 1.216. So that's what I'm going to do. Negative 1.216. And if you think about it, that makes sense. I drew this angle right here in the second quadrant, right? And that gives me a negative x value and a positive y value. So that makes sense. And then I'm going to do the same thing. Instead, I'm going to do 7 sine. And then I'm going to do 5 pi over 9. And that gets me 6.894. 6.894. Okay? So that gets me my coordinate point, and that seems reasonable because if you think about it here, based on what I drew right here, I knew that it was just past 4.5 because it's 5. If I was to draw this little triangle right here down, I'm going way further up and only a little bit to the left, and that corresponds with these two numbers that I've got right there, okay? Now to find tangent, tangent is y over x. So what I'm going to do here would be I'm going to take that 6.894, 6.894, and I'm going to divide that by negative 1.216. And that's what I had for my y value. And I get negative 5.669. So negative 5.669. I could get almost the same value. It won't be exact because we rounded here and here. But if I do tangent, and then I've got 5 pi over 9. That gets me pretty much the same thing. You see, it's real close. It's not going to be exact, like I said, because we rounded this number and we rounded this number. But it's close. So that's a way you can kind of check yourself to make sure that you've got it. Okay. Last problem here. As it says that we've got a figure that shows an equilateral triangle ABO with sides of length 10 in the XY plane. So each one of these sides, this whole thing would be 10, and this side would be 10 as well. Segment AB is perpendicular to the x-axis, so that's telling me that this is a 90-degree angle. The terminal ray of angle theta not shown in standard position passes through point B. So it's just saying that the angle goes through this point right here, through B. So if it's in standard position, that means that I have my initial side here, and it's going through here. So really, I'm looking at this angle, okay? And it wants to know what is the value of sine right there, okay? So if that's what I have, what I need to do is I need to figure out this triangle that I've got right here to figure out my information. So this triangle right here is what I'm looking at. The reason I'm looking at this information right here is because if I can figure out what I have here, it's going to correspond with my sine for this. Because again, remember, if I have my unit circle, so like looking here, this pi over 6 and 5 pi over 6, 30 degrees and 150 degrees, they're the exact same cosine and sine, aren't they? So this 150 degrees that I have right here, if I add 30 degrees to it, I get 180. They are supplementary. Also, that 30 degrees is the reference angle for that 150 degrees, okay? So these values are exactly the same for their x and y. It's just the cosine, the x value is negative because I'm in the second quadrant, okay? So what I'm going to have here to find my sine, if this is what I have right here, what do you think the side length is going to be here to find the height from my x-axis to this one? Well, it's going to be half of that 10. So really, to do sine is opposite over hypotenuse. So it's going to be 5 over 10, which reduces to 1/2. So there's my answer for that one. Okay. Hopefully this all made sense. Let me know if you have any questions.